everybody. My name is Sharon George, and today we're going to discuss about experiment 6 of System Software and Compiler Lab, which is Single Pass Assembler for SIC. So the basic aim is to simulate the concept of single pass assembler for simplified instructional computer. So let's just have a brief description about it first. An assembler is a program that accepts an input as assembly language program, that is a source program, and produces its machine language equivalent, that is the object code, along with the information for the loader. So as you can see the diagrammatical representation of an assembler, it gets an assembly language as input, and then it assembles it. Then we have linker, and then we move on to the executable form of the program that has been given to it. So advantages of coding in assembly language are it provides more control over handling particular hardware components, and it may generate smaller, more compact executable modules, and often results in faster execution. So before moving on to the program, let's just have an understanding or a brief go through the algorithm of the assembler. So you have this input file, so open and read the input file. So if the input file has the opcode, okay, so it's just what's there in the program. Let's just move on to the program and see. It will explain it there. Okay, so I've used the PyCharm editor here. It's an editor IDE especially for Python, specifically developed for Python. So as you can see, we have given I is equal to open input.txt or read lines. So this input.txt is the input file that we are going to give, and here I've written the program. As you can see, copy start 1000. This is all in assembly language. Assembly language. So this is the name of the program. Starting address is 1000. Then load alpha, store beta, alpha reserve word 1, beta reserve word 1, and end. So that's the input.txt file. Okay. Now we have op is equal to open optab.txt, comma r.readlines. Now optab.txt is the opcode table. So here we have the opcode for store as sta as 23 and lda as 00. Now we have four empty lists. One is optab, that's an empty list, and then we have LMNA, which are another four empty lists, and then we have an empty list for opcode and object code. Okay, so these are all empty lists. So we'll be storing the results in these. So for line in OP, so whatever we get in the optab, OP is equal to line dot split, and optab dot update OP of 0 and OP of 1. So we get the two optabs opcodes in the opcode table. Now for line in I, if start in line, so if it is there, start is equal to line dot split. X is equal to int start comma 16 and a dot append with the blank space. Then else a dot append string hex of 2 colon and x plus is equal to 3. Then for line in I, line is equal to line dot split. If length of line is equal to 3, L dot append line of 0. M dot append line of 1 and N dot append line of 2. That's it. So now if we have elif, that is else if, then if else if length of line is equal to 2, we were talking about equal to 3. Now if the length is 2, then you append it with a space, L dot append space, M dot append line of 0 and N dot append line of 1. Then if we have else, M dot append line of 0. So for I in M, if I is equal to start, continue, and if I is present in optab, X is equal to string of optab of I. So whatever is there in optab, we'll store it in X. And Y is equal to str A of L dot index N of M dot index of I. And object code, object underscore code dot append, we get this whole thing. Then object is equal to appended, join it with the space. So space dot join object underscore code. And length leng is equal to length of object code, and x is equal to we're converting it into strings, so typecasting here, hence a hex length star 3. If x in x is equal to x dot replace x comma 0, and print h plus l of 0 plus that upper par symbol plus a of 1 plus a of length of a minus 1, and print t plus a of 1 plus par symbol plus x plus object code. So this is how we are going to display it, and for end we have e plus 00 and a of 1. So I hope you understood this. Now let's just run this file and see the output. So as you can see, we had given the input program, and according to that the assembler has converted it into an object code. So we have h which is the header, the name of the program, copy, the starting address 1000 and 0c. Then we have t, then the starting address, then this is all the code that has been generated from whatever is given there. So I hope you understood. That's the program behind